Good afternoon, everybody. Thanks for coming in today and attending our talk on unified data streaming from change data capture, exactly once processing, AI and ML as a unified platform, and how companies are deploying data streaming at massive scale. So about the speakers, first I'll introduce myself and then I'll introduce Varun. So my name is John Kute. I'm head of products here at Striim. 10 years experience in data management industry. I studied computer science, where that was my first foray into data streaming, where I did NSF-funded research on stream processing from IoT devices coming off of energy-efficient homes. As a side note, I'm also host of What's New in Data podcast, where I host awesome data practitioners on talking about their use cases and what they're deploying in real-world applications. And then I'll give Varun the stage to introduce himself.
Sure. Thanks, John. Hi, everyone. Good afternoon. My name is Varun Verma. I'm currently the VP of Development for Striim Cloud. Prior to this, I worked for AWS for almost 10 years. My last gig there was I was the general manager for their managed Kafka service. Thanks, John.
Excellent. So I'm just going to set it up a little bit Jay Krebs had a similar point during his keynote that data and business events are naturally streaming. I mean, when you think about whether you're a retailer, sales and customer experiences, or logistics, a shipment, if you're in healthcare, a visit with a doctor, service provider, these are all examples of events that happen, and they materialize as event streams. However, due to infrastructure constraints and the current state of the quote-unquote modern data stack, we break streaming data into batches, and that creates a disconnect. Issues with batch processing, especially when you're dealing with event-driven data, is delays in identifying pipeline issues. When you're doing data quality checks or freshness checks, having to constantly pull the staging and raw layers of a warehouse is inefficient. And this inefficiency and cost leads to poor customer experiences with stale data, because you hear so many teams punt on real time because of the inefficiencies of the batch processing engines that they're constrained to work with. And at the same time, the batch processing systems, as you try to boost the throttle, so to speak, and do real-time data via micro batching, the costs are too exorbitantly high, and you ultimately see that as a blocker to adoption, and this leads to more latency as teams basically back off from real-time processing. So here at Confluent Current, and we know that many of you are already well-versed on data streaming, but we'll just give an elementary overview either way. So main characteristics of data streaming is data arrives as events, unbounded, as a sequence of time-ordered events. Processing those events requires high throughput, and processing also requires low latency for data freshness. Now, if you look at a recent history of data streaming over the last 3 decades or so, going back to Tapestry, Niagara, TIBCO, data streaming is not necessarily a new technology, but the current cloud-native ergonomic forms of streaming is modern. And when you look at the time of the Striim implementation, which is around 2012, this overlaps with some of the challenges that were being solved by open source solutions from the large tech companies, such as Twitter Storm, which was popular at the time, and then we saw Spark Streaming start its development shortly after that. And now we're seeing even more modern next generation frameworks built on top of that. Now, Striim's history itself, and I'm going to reference a blog post from Jay Krebs, a very famous one called The Log, since we're here at Confluent Current, where he does talk about Golden Gate. He says Oracle has productized the log as a general data subscription mechanism for non-Oracle data subscribers with Golden Gate. So Striim's founding team was the CEO and CTO of Golden Gate before their acquisition by Oracle. So they bring a lot of deep expertise on logs and processing them and how databases handle change streams. So the way we look at architecting Striim and how it works, we're going to look at it from more of a business data product perspective, which is starting with the operational data, where you have orders, CRM marketing, customer app experiences, and microservices, right? And these might materialize as technical sources such as databases like Oracle, MySQL, or Salesforce, or things along those lines. But we're looking at this from more of a business view. When you think about Striim, it's unifying the core components to build real-time data products end-to-end. So starting with change data capture. Log-based change data capture is a native component in Striim using the main fundamentals of exactly once processing and ordered change data capture, mining the write-ahead logs of the database. Second core component is streaming SQL with a lot of the same semantics supported to do end-to-end exactly once processing from the time you acquire data from a source to writing it, the results of the streaming SQL to a target. And the third component, and Striim's been talking about this, I know there's a big hype wave around AI and ML, but Striim's been talking about this. First presentation of this was at VLDB about 5 years ago on the predictive analytics that Striim has built natively into its product, which is having these components natively in the streaming engine. The fourth one, which is also critical, is schema evolution. So you have any number of business consumers, any number of producers of data, you want to have granular controls over how producers propagate schema changes to specific consumers. Because not every consumer can handle schema changes the same way as their counterpart, right? So you might have one consumer that wants to accept all schema changes, they know how to process it. You might have another consumer, let's say that they're getting data into an operational database, they can't just get an arbitrary alter column statement. So you want them to be able to stop their pipeline, resolve their issue, right? Build a schema parity, and then redeploy their applications, right? So having this granular control over schema evolution is a powerful feature in Striim. Now, when we write these data out to some of the technical infrastructure, right, such as Kafka, Confluent, Google Cloud and all its various components such as BigQuery, Azure, AWS, such as Redshift, Kinesis, Snowflake, Databricks, right? This is all technical infrastructure, but what's the output of this? It's real-time data products, and this materializes in two ways. AI-driven customer experiences, such as smart notifications, chat experiences with private enterprise data that doesn't go out to a third-party SaaS hosted LLM, personalized offers. And you also have operations with real-time, back-end operations with real-time data and machine learning, such as Customer 360, inventory forecasting, real-time sales analytics. So this is really, having this end-to-end pipeline is what allows data teams to ship quickly and deliver data products that have strong SLAs around data quality, freshness, things along those lines. So a lot of times data teams will add a CDC connector and think that that solves a problem. But in just the extent of just getting the raw DML changes, that may be true. But most databases have these very real scenarios, such as records aren't as simple as structured tuples. Arbitrary positioning may be problematic. Unordered schema changes can cause issues to different consumers, right? If you get a schema change and you have some sort of outage and you try to replay the events, you need to make sure that's ordered so you have transactionally consistent data. And also checkpoint dependencies are another challenge. So this has all been solved in Striim, right? When we look at the way that we've implemented change data capture at very detailed granular levels to solve it for business use cases. And what may seem like corner cases, but they can happen on a daily, weekly basis for a lot of enterprises. And you don't want this to lead to a costly resync type of scenario where you have to drop and reinstantiate all your data warehouses and database tables, which can be a costly and time-consuming effort. So that being said, that was my introduction. I'll hand it over to Varun Verma to talk more about how we've architected Striim Cloud.
Thanks, John. Yeah, so like John talked about it, right? CDC, is one big part of streaming data, and the way we at Striim have attempted to solve this problem is that we don't think you need multiple technologies or multiple different services to put together your end-to-end pipeline, right? So there's no need to run a separate layer for connectors, a separate layer for ingestion, a separate layer for processing, right? With the Striim unified platform, in a single box or a collection of boxes which we can cluster together, you get all the rich functionality. Right, so a typical Striim deployment looks like on the left side you'll see a whole bunch of sources, right? Right now we show databases, but this can be anything from Kafka to Kinesis, to all sorts of databases. Right? And on the right side, you see most popular like analytical warehouses like Snowflake, BigQuery, Redshift, or it can also be like Kafka or Event Hub and things like that. In the middle, that is where the Striim platform sits. And in that platform, you can process the data as it moves, and you can also do analytics on it. And we'll dig into a little bit more about how each of those functionalities work. And with the Striim platform, we can do both horizontal scaling as well as vertical scaling. So that means if you're starting off with a single 8-core box, and if as load increases, if you want to make it to 16 cores, you can do that with a click of a button using our managed service. And once the load decreases again, you can again scale down, right, to an 8-core box. Similarly, if you want to partition your data, you can deploy an application to multiple deployment groups, and those deployment groups can be added to multiple nodes, and you can just keep adding more nodes, right? So unlike Kafka, you don't have to write your own consumer applications. You don't have to write your own producer applications. All you're doing is, you're taking a Striim cluster, you're pointing it to a source database, and you're pointing it to your target database, and Striim does the magic. And with our fully managed service, so all available on GCP, AWS, and Azure, we have support for secure dedicated networking, right? So with private link support, the data never hits the public internet. You can just go through the CSP's backbone, and data is encrypted at rest. It's encrypted in transit. So streaming isn't just about moving data from source to target in real time. A lot of times in real world scenarios, you also have to massage the data, right? There can be any reasons. The source and the target might have different formats, right? Or if you want to move certain data where data has to be encrypted or masked or filtered, because of compliance reasons, you need to do that, right? Or the data quality, right? You want to remove duplicates and things like that. So in a lot of similar streaming platforms, you typically end up running yet another component, right, which will intercept the stream, right? Like for example, you might write a Lambda function that does all these things, right? But that just increases the latency. With Striim, all this is packaged in so that you can just move your data from your source to the target and do the processing of the streaming data while keeping the latencies low. So the way this is built in Striim is that you can process data on a per event basis, or you can also process it based on certain micro batches, right? A micro batch can be like a window, which is a time-based window. Say I want to process for 30 seconds, or it can be like activity-based windows, where you can say like process 1,000 events together, or process till 5 seconds of inactivity. So there are multiple ways you can create windows and you can process that data. If you want to write code, we have this concept of a continuous query. This is very SQL, similar to SQL. We have our own language, is TQL. You can write these transformations there, but you can also do a lot of the common transformations using just simple drag and drop UI, and I'll show a demo of that very shortly here. So if you've been paying attention to the conference, the flavor of the conference is Flink, right? Why is that? Because finally the world is realizing that as you're moving data from left to right, and you don't have to wait for your data to be written to the final Snowflake or BigQuery where you want to run your analytics. You can actually run analytics while you're moving the data, right? That's where a lot of people are starting to use Flink. For us at Striim, we've had this functionality for years now, and the reason is that we believe that you really don't need to use a separate set of technologies for these kind of processing capabilities. Again, like with streaming ETL, similarly with streaming analytics, we have built native functions for stuff like linear regression, multiple linear regressions, polynomial regressions, and you can write all these capabilities with using real simple SQL code. We also support open processors, which is if you want to do really complicated stuff, like maybe invoke an AI model or maybe invoke an LLM that wants to create your own vector embeddings and store them in a vector database. You can do all those powerful things as well by writing simple Java processors. So let me just quickly show a demo here of how this really works. So this is Striim Cloud Enterprise running in GCP. So I'm just going to launch the service here. So this is one of the applications that we have. So this is actually kind of what an application looks like in the Striim world, like a pipeline. What this pipeline is going to do is, it's going to read data from Oracle, and it's going to write it into BigQuery. And while that is happening, we're going to do some simple transformations in the data, just like convert certain fields, right? And also, we're going to run that data through a window. And in that window, we're going to process that data and run a simple linear regression model. And what that linear regression model is going to do is it's going to predict, right, whether a particular value. So in this case, we're using an example of inventory, right, like inventory, retail inventory, like shirts or jackets and things like that. And that data is moving from Oracle to BigQuery, and the output of the linear regression model is that are we going to run out of inventory for that particular product, right? And if the answer is yes, there is a high confidence, right, like a 90% confidence that, yeah, we are going to run out of that, you can write an alert to Slack, whatever Slack you have set up. And there's several other ways of notification. With this demo, we just set up Slack. So, and this is kind of what, like simple, the TQL looks like, right? What we're doing here is, and I'll show you what the Oracle source looks like, but we're just converting some of the fields here into more user-friendly formats. And then this is what it looks like if you want to say that as data is flowing through, I want the data to be partitioned using a skew. And then as you're processing the data, run it through a linear regression model. And if there's a 90% confidence that you're going to run out of inventory, then issue an alert to Slack, right? Just writing all that logic to move from Oracle to BigQuery and process it through linear regression model and write an output to Slack, you can do all this from one pane of glass. You don't really need to go write separate functions, spin up different separate services, manage all your infrastructure from separate places. You get all that with a single unified platform. So I'm just going to run a recording here of what the video looks like. So this is the low inventory app that we just talked about. So this is what the Oracle database looks like. We have very simple data in here that kind of shows, that you have a whole bunch of items, and what their inventory levels look like. So we're going to just as an example, look, what does the inventory for, rain boots looks like. And as that data is being written to BigQuery, we're going to run it through the window that we talked about. That's the definition of a window. It's defined as a session. And that's the simple linear regression model that we're going to run through. And the output of that is, a Slack. So when you deploy the app, as you can see the numbers at the top that shows as data is flowing through, we are processing data. So far we've processed about 6,000 events. And one of the cool things about the Striim UI is that as data is flowing through a pipeline, you can put an eye on it, and that lets you see the data as it is flowing through the pipeline. And this just shows the Slack channel that has been processed. So you can see the number of messages that have been processed. This is a pretty simple demo, so we're processing about 14 messages per second. And for 2 of these items, the model predicted that there's a 90% chance that you're going to run out of that inventory for that, so it just outputs a Slack message. So switching back to the slideshow here. Yeah, so this is the demo. John, do you want to talk a little bit about how companies are actually deploying Striim?
Yeah. First round of applause for Varun, everybody. Thank you for the demo. So I know we're about at time. So one quick story that I wanted to share was, how are companies actually using Striim today and empowering their teams with data streaming? So tech ops and maintenance at American Airlines, they're the folks running around your airports with vests on, right? They have the iPads in hand, and they're actually powered by data streaming operations. All aircraft telemetry in real time is surfaced as data products to different consumers. And one of the great things here is, we're talking about a single pane of glass. This means they get to ship fast. So at global scale, they're sourcing aircraft telemetry, using it for flight operations. They were able to go to production in 12 weeks. And this is for a major airline and a critical operation. So, there's several dashboards that they power with this. And, you hear about Kappa architecture, which is streams into batches. This is a real world implementation. You can see that they use this for remain overnight maintenance at stations and hourly aircraft reports. So if you read that paper on stream processing in a spreadsheet, this is the closest we're going to get to that, where streaming data is feeding data that goes into a report and into a spreadsheet model that they email out to their business users. So even though emails are going out on a 30-minute or hourly cadence, stream processing and real-time data ensures trust and accuracy in that data as it goes out to executives. So I'll leave it there. Thank you everyone who attended the talk today. If you want to try Striim, it's available for free. We have a free forever service. We also have free certifications for generative AI and streaming on our academy. So if you go ahead and scan this, you'll get access to that. No credit card required. Free forever SaaS service for data streaming up to 10 million records per month. And we invite everyone to really just try it out for themselves. You'll see the exact same user interface that Varun demoed to you today. And thanks again for attending, and thank you to Confluent for hosting this event. I'm John Couttet from Striim, and we had Varun Varuma as well.
Thank you, everyone.